The Baudot code, invented by Émile Baudot, is a character set predating EBCDIC and ASCII. It was the predecessor to the International Telegraph Alphabet No. 2, the Teleprinter Code in use until the advent of ASCII. Each character in the alphabet is represented by a series of bits, sent over a communication channel such as a telegraph wire or a radio signal. The symbol rate measurement is known as baud, and is derived from the same name. History Baudot code technically, 5-bit codes began in the 16th century, when Francis Bacon developed the cipher now called Bacon's cipher. However, this cipher is not a machine cipher and as such is not readily suitable for telecommunications. Baudot invented his original code in 1870 and patented it in 1874. It was a 5-bit code, with equal on and off intervals, which allowed telegraph transmission of the Roman alphabet and punctuation and control signals. It was based on an earlier code developed by Carl Friedrich Gauss and Wilhelm Weber in 1834. It was a gray code, nonetheless. The code by itself was not patented because French patent law does not allow concepts to be patented. Baudot's original code was adapted to be sent from a manual keyboard, and no teleprinter equipment was ever constructed that used it in its original form. The code was entered on a keyboard which had just 5 piano-type keys, operated with 2 fingers of the left hand and 3 fingers of the right hand. Once the keys had been pressed they were locked down until mechanical contacts in a distributor unit passed over the sector connected to that particular keyboard, when the keyboard was unlocked ready for the next character to be entered, with an audible click to warn the operator. Operators had to maintain a steady rhythm, and the usual speed of operation was 30 words per minute. The table on the right showed the allocation of the Baudot code which was employed in the British Post Office for continental and inland services. It will be observed that a number of characters in the continental code are replaced by fractionals in the inland code. Code elements 1, 2 and 3 are transmitted by keys 1, 2 and 3, and these are operated by the first 3 fingers of the right hand. Code elements 4 and 5 are transmitted by keys 4 and 5, and these are operated by the first 2 fingers of the left hand. Baudot's code became known as International Telegraph Alphabet No. 1, and is no longer used. Murray code In 1901 Baudot's code was modified by Donald Murray, prompted by his development of a typewriter-like keyboard. The Murray system employed an intermediate step, a keyboard perforator, which allowed an operator to punch a paper tape, and a tape transmitter for sending the message from the punch tape. At the receiving end of the line, a printing mechanism would print on a paper tape, and/or a reperforator could be used to make a perforated copy of the message. As there was no longer a direct correlation between the operator's hand movement and the bits transmitted, there was no concern about arranging the code to minimize operator fatigue, and instead Murray designed the code to minimize wear on the machinery, assigning the code combinations with the fewest punched holes to the most frequently used characters. The Murray code also introduced what became known as format effectors, or control characters the C and LF codes. A few of Baudot's codes moved to the positions where they have stayed ever since, the null or blank and the del code. Null blank was used as an idle code for when no messages were being sent. Early British Creed machines used the Murray system. Western Union Murray's code was adopted by Western Union which used it until the 1950s, with a few changes that consisted of omitting some characters and adding more control codes. An explicit SPC character was introduced, in place of the blank null, and a new bell code rang a bell or otherwise produced an audible signal at the receiver. Additionally, the WRU or, who are you? Code was introduced, which caused a receiving machine to send an identification stream back to the sender. ITA2 Around 1930, the CCITT introduced the International Telegraph Alphabet No. 2 code as an international standard, which was based on the Western Union code with some minor changes. The U.S. standardized on a version of ITA2 called the American Teletypewriter Code which was the basis for 5-bit teletypewriter codes until the debut of 7-bit ASCII in 1963. ITA2 is still used in TDDs, telex, and some amateur radio applications, such as radio teletype. ITA2 is also used in enhanced broadcast solution to reduce the character encoding footprint. Nomenclature: nearly all 20th century teleprinter equipment used Western Union's code, ITA2, or variants thereof. Radio amateurs casually call ITA2 and variants baud incorrectly, and even the American Radio Relay League's Amateur Radio Handbook does so, though in more recent editions the tables of codes correctly identifies it as ITA2. Details: note, this table presumes the space called 1 by baud and Murray is rightmost, and least significant. The way the transmitted bits were packed into larger codes varied by manufacturer. The most common solution allocates the bits from the least significant bit towards the most significant bit. In ITA2, characters are expressed using 5 bits. ITA2 uses 2 code subsets, the letter shift, and the figure shift. The figs character signals that the following characters are to be interpreted as being in the figs set, until this is reset by the LTRS character. In use, the LTRS or figs shift key is pressed and released, transmitting the corresponding shift character to the other machine. The desired letters or figures characters are then typed. Unlike a typewriter or modern computer keyboard, the shift key isn't kept depressed whilst the corresponding characters are typed. Inquiry will trigger the other machine's answer back. It means, "Who are you?" CR is carriage return, LF is line feed, bell is the bell character which rang a small bell, SP is space, and NUL is the null character. Note: the binary conversions of the code points are often shown in reverse order, depending on from which side one views the paper tape. Note further that the control characters were chosen so that they were either symmetric or in useful pairs so that inserting a tape upside down did not result in problems for the equipment and the resulting printout could be deciphered. Thus figs, LTRS and space are invariant, while CR and LF, generally used as a pair, are treated the same regardless of order by page printers. LTRS could also be used to overpunch characters to be deleted on a paper tape. The sequence RYY is often used in test messages, and at the start of every transmission. Since R is 01010 and Y is 10101, the sequence exercises much of a teleprinter's mechanical components at maximum stress. Also, at one time, fine-tuning of the receiver was done using 2 colored lights. A YY produced 010101001, which made the lights glow with equal brightness when the tuning was correct. This tuning sequence is only useful when ITA2 is used with two-tone FSK modulation, such as is commonly seen in radio teletype usage. US implementations of baud code may differ in the addition of a few characters, such as, and on the figs layer. The above table represents the USTTY code. The Russian version of baud code used 3 shift modes. The Cyrillic letter mode was activated by the character. Because of the larger number of characters in the Cyrillic alphabet, the characters and a pound were omitted and replaced by Cyrillics, and Bell has the same code as Cyrillic letter TH registered trademark. See also, serial communication, asynchronous communication, Morse code, AY, punch tape. Notes. References: Copeland, B. Jack, ed., Colossus, The Secrets of Bletchley Park's Code-Breaking Computers, Oxford, Oxford University Press, ISBN 978-0-19-284055-4. Hobbs, Alan G., Nadorm Papers and Writings, 5-Unit Codes, retrieved April 15, 2012, Jennings, Tom. An Annotated History of Some Character Codes, Baudot's Code. Retrieved April 26, 2014. MTK2 Code Table, Baudot, Murray, ITA2, ITA5, etc. Jean Morris A Permel Mild Baudot. Archived from the original on September 13, 2009. Online text ITA2 Converter, a breakdown of the patent for Baudot's first device. This article is based on material taken from the free online Dictionary of Computing prior to November 1, 2008 and incorporated under the relicensing terms of the GFDL, version 1.3 or later.